Hi everyone, welcome back to my channel and thank you so much for joining me today. So today I'm going to be using Gemini to create some simulations that support mathematical conceptual understanding. So if you're interested in coming to explore how to use Gemini in the mathematics classroom, then please keep on watching. Okay, so recently I was working with a mathematics group and they were saying to me that they cannot see any point of using any AI in terms of mathematics learning. And I said, oh, that's very interesting that you say that. So in this video, I wanted to explore some really meaningful ways that we could use AI in the mathematics classroom. So let's take a look. Okay, so last week I talked about the uses of Google Gemini. I'm really happy that it's available in Hong Kong without a VPN. And I said, can you give me 5 examples of how AI Gemini can be used to create a simulation for mathematics? So I actually haven't said create the simulation yet. I'm going to choose one of these ideas that I think is really good, and then we're going to create that simulation. So using Gemini to build math simulations turn abstract formulae into interactive visual playgrounds by asking Gemini to generate HTML, CSS, or JavaScript. Yeah, students can manipulate variables and watch mathematical concepts unfold in real time. So I love this idea of the Galton board. I used to actually have a physical one with my students where they would actually drop balls and record results physically. So I really do think that there's value in using a physical Galton board. But sometimes if we want a high number of trials, we don't want to waste students' time in a class dropping the balls through a Galton board for half an hour, right? If they can actually just easily do this using AI or a simulation. So here, the Galton board, it's really about normal distribution and binomial probability. Show how random binary choices, like when the ball goes left or right, aggregates into the predictable bell curve, which is, talking about the central limit theorem. How Gemini builds it. Gemini creates a physics-based visual grid of pegs. Virtual balls drop from the top, bounce left or right with a 50% probability, and collect in bins at the bottom. So what's the inquiry angle? And then I think I need to know the prompt in order to create this, right? And I might also have to change my Gemini model. So the inquiry angle is that students can change the bias of the pegs, right? So put 60% to bounce right or using a slider, and observe how the entire distribution curve skews across the grid. Okay, I really like that idea. So, look, well, let's just have a quick look at the other ones and then let me build that one. So projectile motion tracker for quadratic functions and kinematics. So we put in the general quadratic function here, ax squared plus bx plus c. And then Gemini will build a simple dashboard featuring canvas-based animation, a launcher fires, an object drawing a smooth parabolic arc across an XY grid while plotting the corresponding algebraic equation dynamically below it. But we actually want students to interact with this, right? We don't want to just ask them to watch something and then the AI tool gives them the answer. So what's the inquiry angle? I like how they've phrased that. Instead of just giving the physics variables, students adjust sliders for initial velocity, launch angle, and gravity. They have to find the exact mathematical combination needed to hit a target coordinate on the screen. I love that. Okay, so I won't read the rest of them out, but let me just put, I'll just put this. It's in the same conversation. So let me see. I'm going to say dictate to text. For the following idea, can you please build the activity so that students can change the bias on this particular Galton board? Okay, and then let me just copy and paste what that is. Now, I need to change the model because I do want advanced maths and code. So let me just click on that. The thinking, I kind of want complex, best for most questions. Okay, so let's keep it at standard. I hope I have enough credits for this because I'm on the free version. So I'm going to submit that. And then let's see what happens. Now, I might have to hit the pause button if it's going to take too long. Manus normally takes about, I don't know, a minute, not very long. But if this is going to take about 5 minutes or so, I will hit the pause button. But so far, it's saying it's generating the widget, refining the specification, and it hasn't even been a minute. And now it's building the widget. Okay, and then it's done. Okay, so that was like literally 1 minute. Okay, let's see. It says, here is the fully interactive Galton board. Okay, exactly for that inquiry angle. Instead of looking at a static textbook graph, you can run this now to test the physics. The bias slider allows you to manipulate the underlying probability of the system in real time, shifting the distribution curve before the balls even hit the bottom. Okay, so it's generating now, structuring the code. This may take a minute. All right, so I'll just let that, so it hasn't actually finished, but at least it's telling me. Okay, oh, here it is. Okay, I'm glad that I didn't hit the pause button. All right, so we drop a ball. Okay, lovely. Keep dropping balls. And this is the bias count. Okay, drop speed, drop 100 balls. Okay. And then running the inquiry activity. This is the most important thing because I know that we can probably find this online, right? There are probably some websites that have actually already built this applet. But, I think that it's nice how we can adjust the probability and create a bias in the ball bounce. So here, running the inquiry activity, phase 1, 0.5 bias. So it says start by leaving the bias exactly at 50%. The prompt, ask students, if every peg gives the ball a 50-50 choice, why do most of the balls end up in the exact center instead of spreading out evenly across the bottom? I love that question. And the goal, get them to realize there's only one pathway to reach the far left bin going left every single time, but dozens of zigzag pathways that lead back to the center. And then phase 2, so I love how Gemini suggested these different phases for the inquiry activity and how it's really interactive and asking students to analyze and to critically evaluate, right? So phase 2, stop the simulation and clear the board. Tell students you are moving the bias to 0.7. I mean, I might ask students in groups to have one simulation on their laptop, and then in groups of 2, maybe pairs, look at one laptop, because we don't want students to be working in isolation. We want them to be able to discuss and collaborate. So now we're moving the bias slider to 0.7, and the prompt that we're going to pose to students is draw what you think the final stacks will look like. So before they see the answer, will the entire pile just shift to the right, or you think the shape of the pile will completely change? And students often assume the exact same bell curve will just slide over. And then phase 3, you reveal and you discuss the maths, right? But you want students to go through that productive struggle first. Drop 100 balls and let them watch the skewed distribution form. The prompt, now you can see the skewed curve. How would you write an equation to predict the most likely bin a ball will land in based on the slightest percentage? And the goal is to create a natural bridge from the visual simulation straight into calculating expected values, right? Where n is the number of rows and p is the probability of that bias. And then it says, want to build the projectile simulation next? This is brilliant. Okay, so that was just one example of how to incorporate inquiry-based learning into the mathematics classroom using AI and really focusing on deep conceptual understanding. I get this question a lot from maths teachers. All of the models, they just give the answers, but we can actually design and create different, I think, interactive, inquiry-based mathematics learning experiences for our students that can really support their understanding. And that was just one example. So if you have other examples, please feel free to put it in the comment section below. Please remember to hit the subscribe button, and that really helps to keep this channel afloat. And I hope to see you next time. Bye.